gate questions on queues. See this question, a previous gate question. Consider the following sequence of operations on empty stack. Okay, push 54. So I have an empty stack with me. Push 54. I am pushing 54. Then again push 52. I'll be pushing 52. Then we have pop. Pop means we have to delete the top of the stack. So 52 is deleted. Then we have push 55. So 55 is pushed. Then we have push 62. So 62 is pushed. After that, we have S equal to pop. S is equal to pop. If you pop, what you will get? You will get 62 as the element. This is deleted and S becomes your 62. In the same way, consider the following sequence of operation on an empty queue. So there is a queue here. Okay, there is a queue. NQ21. So from this side, 21 is inserted. It comes here. Then NQ24. Then DQ. When you delete, the front part is deleted. From here we delete it. So this 21 is deleted. Okay. Then again NQ28, NQ28, NQ32, NQ32. Then Q is equal to DQ. So in Qs, where do we delete the element? We delete at the beginning. Here is my front. Okay. So Q value becomes 24. So question is very simple. What is the value of S plus Q? What is the value of S plus Q? Right. So the S value is 62, Q value is 24. If you just add these two, it becomes 86. 86 is the answer. Okay. So it's a simple question based on stacks and Q combined together. Right. Let's see next question. See here, GATE CSE 2022 question. Consider the queues Q1 and containing 4 elements. There is a queue Q1 with 4 elements, 1, 2, 3, 4. And Q2 contains none. Okay, you see here Q2, there are no elements. It is empty queue. Okay, the only operations allowed on these two queues are NQ, that is Q element, and DQ. Okay, generally we know on queues we can perform only 2 operations, that is NQ and DQ. On these 2 we can perform. The minimum number of NQ operations on Q1 required to place the elements of Q1 in Q2 in reverse order. So this is the initial state, this is the final state. So Q1 is like this 1, 2, 3, 4. They want us to fill Q2 like this 4, 3, 2, 1. So how many number of NQ operations you should do to make this Q2 look like this 4, 3, 2, 1? Okay, you just guess the count. How many number of NQ operations are required to fill the Q2 in this order 4, 3, 2, 1. See, how many NQ operations on Q1 required to place the elements of Q1 in Q2. On Q1, how many NQ you should do to fill the Q2 as 4, 3, 2, 1. So the question is, what are the number of NQ operations on Q1? Okay, what are the number of NQ operations? Right. So if you see here, if you observe here, see, this is what I'm just underlying this on Q1. Now, if I want to fill the elements 4, 3, 2, 1 like this, what I have to do? First, you have to do DQ on Q1. So this becomes 1. Generally, when you want to remove that, when you want to remove 1 and fill into Q like this, you will remove this and you will fill it here. But is it filling like that? No, we cannot fill it. Only thing we have to do DQ operations, right? We have to perform DQ operations. Okay, so here see, number of NQ operations on Q1 required to place the elements of Q1 in Q2 in reverse order without using any additional storage. Okay, can you get this without additional storage? Without, meaning you cannot use any array, you cannot use any stack. I want to fill these things like this 4, 3, 2, 1. How can we do that? Right. So NQ operations on Q1. See, this is not possible. I cannot bring the, in Q I can only delete at the front. If I delete, if I delete this one, if one is deleted, right, that one, where what can I do? I can insert in Q2. So it becomes like this. If I delete here, it comes like this. If I delete, it comes here. So DQ, even if you're doing, you're unable to find 1, 2, 3, 4. Right? Even if you're doing DQ, you're unable to find 1, 2, 3, 4. So what can be done here? You cannot use stack also. And I want 4, 3, 2, 1 order. Right? That's why in this case, the number of NQ operations is 0. Why? It is not possible for us. Even if I do like this, even after deleting this, maybe if we elaborate, if I delete this 4, this is the order which I am going to get in Q2, 1, 2, 3, 4 only, right? Again, if I keep pushing the elements into Q1 from Q2, same thing, 1, 2, 3, 4 goes here. It is not possible to get this order with this NQ and DQ operation, right? Because we can perform deletion. If I am performing deletion, first one is getting deleted, 1 comes here, 2 gets deleted, 2 comes here. That's why the minimum number of NQ operations on Q1 is 0. Okay, right. Let's see the next question. Consider a sequence of elements A0 equal to 1, A1 equal to 5. Please see this question. Let's understand this problem. Consider a sequence A of elements A0 equal to 1, A1 5. We are given some set of sequence of elements. The following operations are performed on stack and queue, both of which are empty. Okay, see, push the elements of A from A0 to A5 in that order into S. So I have a stack here. I have to push A0 to A5. Only so 1 comes here, then 5, and then 7, then 8, then 9, and on top I have 2. This is my stack. Then NQ the elements of A from A0 to A5 in that order in Q. Meaning in the Q I have to insert the elements in the same order. So 1, then 5, 7, 8, 9, 2. Here I can delete, here I can insert. Pop an element from S. Okay, pop an element from S means 2 is removed here. 2 has gone. I have popped 2. DQ an element from Q. DQ means delete. So 1 gets deleted here. Okay, 1 gets deleted. Now pop an element from S again. So 9 gets deleted. Again, DQ an element from Q. So this 5 also gets deleted. DQ an element from Q and push the same into the stack. Meaning you DQ the element 7 and push that onto the stack. Next, repeat operation 7 3 times. So what we have to do here? 3 times means DQ from Q, push it into the S. So DQ from Q8, push it here onto the stack. Again, delete 9, put it here. Then delete 2, put it here. Like this, my stack. Pop an element from S. So 2 goes away. When I pop it, 2 goes away. Now again, pop an element from S. 9 also goes away. Right? Currently, my top of the stack is 8. The top element of S after executing the above operation is, what is the top element? 8. So answer here is 8. Simple question. Only thing, you have just to draw the diagram and carefully fill the what we say, stack and queue both. I hope the question is clear. Very simple. Perform each operation in step by step and find out what is the value. Right? GATE CSE 2023 recent question on, again, most probably when you see previous GATE questions of data structures, you will definitely find stack and queues combined together. Okay, let's see next question here. Right, let Q denote a queue containing 16 numbers. In a queue there are 16 numbers and S be an empty stack. S is an empty stack. Head Q returns the element at the head of the queue without removing it from Q. Head Q will without removing. Similarly, top S returns the top of the S without removing it from S. Consider the following algorithm. There is some function or some while loop is given while Q is not empty. Do if S is empty or top of S less than or equal to head, then DQ push else do this thing. Okay. So the question here is the maximum possible number of iterations of the while loop in the algorithm is how many times this while loop will execute is the question. Okay. How many times this while loop will execute. So you can, let's discuss the solution for this. See, they're asking maximum possible number of iterations. Let's take case 1. I have a queue with me with elements 1 to 16. Okay, 1, 2, 3, so on. I have till 16, right? And stack is currently empty. Queue is not empty. Yes. If S is empty, true. This is satisfying. If S is empty, X equal to DQ this queue means 1 is deleted from here. Push that onto the stack. 1 comes here. Again, after this, it will not go to else. It will go back to the upper while. Is queue empty? No. So, queue is not empty. Second time while loop is iterating. Is S is empty? No. Now, top of S less than or equal to head of Q. Yes, top of S less than or equal to head of Q. What is there in top of S? That is 1 less than or equal to head of Q. Head of Q is 2 now. This is true. So, again delete this element 2, put it here. Same way, again go back. Third time, 1 over, 2 over, third time. 3, top less than, yes, top is less than this element. So, 3 comes here. This gets deleted. This way, this loop will be repeated 16 times until the queue becomes empty. Until the queue becomes empty. This is one case. This is one case. We understood that this will repeat for 16 times. But what if the elements are like this? 16, 15, 14, and so on till 1. This is my queue status and my stack is empty. Okay. So, while queue is not empty, yes, one time. Is S is empty? Yes. I don't bother about this. S is empty. Yes, enter. X equal to DQ. Remove 16. Push S. So, 16 comes here. First condition satisfied because stack was empty. Right. Next. Second time, 1 over. This time, second time. S is empty? No. The top of S less than head. Head contains 15, top contains 16. Is it true? No, it goes to else part. What is that else part? X equal to pop of S. X equal to pop of S. So, delete this 16 that is there in X NQ. Add 16 here at the end of the queue. Add 16 at the end of the queue. Right? So, 2 times over. Next, third time, it will go third time. S is empty? Yes. So, DQ and push. So, 15 is deleted, 15 comes here. Next, fourth time. Is S empty? No. Is top of S less than head? Is this less? Top of S is 15. Head contains 14. Is this condition true? No. It will go to else. What I have to do? Pop S, delete this 15 and insert here. Right? So, this become, now again, fifth iteration. It goes like this. How long will it keep doing this? See, first time it is doing total 32 times. 31 times, I guess. 30, no, 16 was there here, 16 was inserted. 1 time, 2 time, 3 time. After 4 iterations, no, we got 16 and 15 here. Fifth iteration, 14 is getting deleted, 14 is coming here. This is deleted. I have 13 here, right? So, again, is it true? No, it come to else. It will pop this 14 and put it here, right? Like this, if you keep doing, you will keep repeating this process. How long will it repeat? See, numbers from 16 till 1 are there. We are deleting everything because always it is going to else part. Always it is going to the else part. We are adding them again to the list. So, the list becomes again 16, 15, so on. Again, you keep doing this repeating process, right? So, how long will you think it goes in this repetition process? Just guess. See, I hope you understood it. We are deleting, we are inserting, right? No, it will not go to infinite. Why it will not go to infinite? At some point, see, let me execute this and show you, because at some point this condition will true. Sometimes this is getting true, sometimes this is getting true. Okay, maybe 1 is there here, after 2, 3 was here, condition failed. So we deleted 3 and added here, added at the end of the queue, we added 3. Then we had 2. You will pop this 2, you put it here. The condition failed. This is 1, this is 2, condition failed. You will give 2 and put it here. Now it is empty. You will remove 1 and put it here. Now you see 16 is greater than 1. Q is not empty and 1 is not there. It will be added again here. It goes to, no, if this is true, you are dequeuing that and pushing onto the stack. So you are deleting this and putting 16 here. Okay, 1 came, but later this is also coming. So you have 15. So you will be deleting it sometimes. What is the pattern here? Can you identify the pattern? See, first time when we are coming to this, okay, total after 31 iterations, okay, if you try this in the reverse possible case, if 16, 15, 14, so on, 1 is there and stack is empty, right? The stack will become empty again. Stack will become empty again after 31 iterations. In this sequence, while loop is running 31 times. Q will become empty after certain point. See, Q is not empty. After certain point, Q will become empty. That is after 31 iterations. In this pattern, okay, in this pattern, it will become, okay, again, this is a little lengthy problem, but still, you can let us execute this for few iterations. 16, 15, 14, 13, so on, 1. This is empty. I have Q is not empty, S is empty. So therefore, X equal to DQ. 1 iteration. Okay. This 16 is being removed. 16 comes here. Next. After that, again, Q is not empty. S is empty. No. Top S less than head. No. Come to the else part. What I am doing here? X equal to pop S. Remove this. 16 comes here. Again go back. 16 is added back into the Q. Right. Again go back. Q is empty. No. So second iteration. This is second iteration. Right. So Q is not empty. S is empty. Yes. Then DQ. Remove this 15. Include it here. Again go back to the iteration. Third iteration. Q is empty. No. If S is empty. No. Top less than head. No. Do the else part. Pop this 15. Sorry. Pop this 15 here and add it back here. 15. Again, next fourth iteration. Q is empty. No. S is empty. Yes. DQ this 14. Add it back here. 14 comes here. Right. Next, again iteration 5. Q empty. No. S is empty. No. Top less than head. No. Come here. Pop this 14. Add it back here. Okay. Again go back. Next, sixth iteration. Q empty. No. Is S empty? Yes. So remove this 13. Add it back here. Okay. Now again go back. Here contains 12. Go back. Is Q empty? That is seventh time. Is Q empty? No. Is S empty? No. Top less than? No. Do this else part. Delete this 13 and add it here. Like this. See, after 7, 13 came. After 8, 12 will be gone. After 9, 11 will be gone. 10th iteration, 10 will be gone. 11th iteration, 9 will be gone. 12th iteration, 8 will be gone. Same way, 13th iteration, 7 will be gone. Sorry, 7 will be deleted. After 14th iteration, 6 will be deleted. 6 will be deleted. It is being added there. Okay, see that. 15th iteration, 5. Same way, 15th, 5. Then 16, 17, 18. That is 4, 3, 2. Right. Now, the 19th iteration comes. What is there? 1 is left here. What will be there here? 2 will be there here. Because 2 is deleted and kept here. After 19th iteration, what I have to do? I have to pop this 2, add it back here. I have to pop this 2, add it back here, right? This is gone. So after 19th iteration, here after this Q is in the 19th iteration, the stack is empty. Now what I have to do is stack empty? No. Top of head was 2 less than head, 2 was here initially. 2 is less than 1? No. So we have popped it and added back. Okay. Then next one is stack empty? Yes. X equal to Q. 1 is deleted, added back here. So 19th iteration 1 is deleted. 19th iteration 1 is deleted. After this, what we are doing? After deleting 1, what we are trying to do here? What we say? Yes. Since S is empty, delete this and add to the stack. Again go back. 20th iteration. Is stack empty? No. Top of S less than head? Yes. 16 is less than head. Right? 16 is less than head. Oh, sorry. This 1 is less than 16. Then comes your 16 here. Okay. This way it will keep repeating. No, it will do it for 31 times. Then the Q will become empty. This will repeat, not 31 times, but first cycle is for 31 times. Okay, first cycle is for 31 times. Then, if this case, again it will repeat. Again it will repeat. It will become 29. It will become 27 times. Why? See, why the number of iterations have come down here? 1 and 16 is there. After 2, 3 like this, 16. Here it is changing 2 times. Again after having 15, again you are having 16 and 1 in the second cycle. So it keeps on reducing. It will keep repeating 16 elements plus 25 plus 23 plus 21 plus so on plus 1. So this, if you sum, it becomes 256 times. Okay, little complex problem. You try it. You take a very big rough paper and try it and see this. You take, maybe you can take small number. Maybe you can take small number and do this. Instead of 16, you may take 4 numbers and then see how it is working. After how many iterations? After how many iterations we can do that? We can still do that for 4 numbers. Let us try. I have 4, 3, 2, 1. Assume this is the case. My stack is empty. Okay. Q is not empty. Stack is empty. Yes. Delete this 4. Add it back here. This is first time, no? I'll just delete. This is first time. First time this happened. 4 came here. Now again go back. Second time. Is Q empty? No. Is S empty? No. Top less than head? No. X equal to pop. Remove this 4. Add it back here. Next, third iteration. Is Q empty? No. Is S empty? Yes. Remove this 3. Add it back here. Again, fourth iteration. Is Q empty? No. Is empty? No. Top of S less than head? No. Come here. X equal to pop of S. So remove this 3 and add that 3 here. Next, fifth iteration. Is Q empty? No. S empty? Yes. Delete this 2. Include it here. Again, sixth. Q empty? No. S empty? No. Top of S less than head? No. Come here. Pop this S. Put it back here. Next, seventh time. Q empty? No. Is S empty? Yes. DQ and push. Remove this 1 and put it here. Next, eighth time. Is Q empty? No. S is empty? No. Top of S less than head? Yes. Top of head is less than this. Then DQ this 4, add it to the stack. So this contains 1 here. On top comes 4. So 4 is deleted this time from the Q. 4 is deleted from the Q. Again, ninth time. Q is empty? No. S empty? No. Top of S less than head? 4. 3 less than top of S 4. Is 4 less than 3? No. Then pop this 4. Add it back here. Okay. Again, 10th iteration. Q empty? No. S empty? No. Top of S less than head? Yes. Then X equal to DQ. Add this 3 here. Like this. Next, 11th iteration. Come, Q is empty? No. Yeah, Q is not empty? Yes. S is empty? No. Top of S less than head? Is 3 less than 2? No. Pop this 3, add it back here. Again, 12th iteration. Q empty? No. S is empty? No. Top of S less than head? Yes. In this case. So DQ this 2, add it back here. right? So again, 13th time, 13th iteration, Q empty, no, it has 4 and 3 elements in this. S is empty, no. Top of S less than head, yes. Top of head is less than head. So because 2 is less than 4, then remove this 4, add it back here. Okay, next 14th iteration, Q empty, no, it has some element. S is empty, no. Top of S is 4 less than 3, no. Then DQ this 3, add it back. 4 is less than head, no. So it will come down. Pop this S, remove this 4, add it back to this. Now your Q becomes 3 and 4. Your Q becomes 3 and 4. Next, 15th iteration, Q empty, no. S empty, no. Top of S less than head, yes. This 2 is less than 3. 2 is less than 3. So what I have to do? I have to DQ this Q, add it back to the stack. Next, 16th entry, Q is not empty, true. S is empty, no. Top of S, 3 less than 4, yes. Then DQ this and add it to the stack. See, when there are 4 elements, it is doing 16 iterations to make the Q empty. Right? If there are 4 elements, it is doing 16 iterations to make this empty. If there are 16 elements, then 16 square, that is 256 iterations it will do. Okay, so this way you can justify the answer. We have seen an explanation how we are trying to delete the elements and add it to the making this Q empty. So this Q is empty now, it will come out of the loop. How many times it happens? 16 times, when the number of elements we have taken as 4. So if there are 16 elements, total 256 times this while loop will execute to make the Q as empty. Therefore, the answer for this is 256. See, but when you take the elements as 1, 2, 3, 4, we are getting only 16 times. That's why they are asking maximum possible number of iterations. The order in which the numbers are stored is not given. So always choose the worst case, that is, assume that in the elements in the queue are arranged from 16 to 1. Okay, let's see one more question. Please see this. Try to understand this question. See this question. A queue is implemented using array such that NQ and DQ operations are performed efficiently. Which of the following statement is correct? Okay, so generally what is the time taken for deleting an element or inserting an element? Inserting element, again we know, see, we are doing in the queue, or maybe in circular queue also, if you take, right? So I know I have a pointer already, rear and a front. Okay, and if you see the implementation, it is just one step. We are not doing any iteration, because just to increment rear value to the next rear value, rear plus 1 modulo the capacity you do and put the element there. One time activity. Okay, constant operation. If you want to delete element, you move your front and delete this. Again, one time operation. We are not doing any iteration. Therefore, you see options, both operations are performed in order of one time. Yes, this is the answer. Why? They require only one operation. Let's see the implementation of Q. I'll just show you here. See the circular array implementation. In NQ, in inserting, there is no looping here. Just one constant step. This is happening one time. In DQ also, there is no looping statement here. Just one step. Just increment it and delete that. That's why the time complexity of both of these elements inserting and deleting is one time. Again, a previous GATE question. So the operations are performed in order of one complexity. Yeah, that's it about these are again few simple GATE questions on Q data structure. But mostly, if you see, they appear with the combination with the stacks and Q, right? Both appear in combination. See here, this is also combination question. This is also a combination question with stacks, right? These are few applications of what we have studied. We are just seeing whether we are able to solve them using our knowledge or not.